All right, so here's this water simulation thing I worked on. So it's like a 2D grid. You're kind of as if you're viewing it from the side. It starts off paused. So these brown ones are kind of solid blocks. The blue is the water. And I'll unpause the simulation here. So yeah, just the water starts flowing down, and it has kind of a level finding mechanic to it, to where it'll slosh off to the side as best it can. And you can see here it's kind of filling up in this depression. And I also have this log on the right where I kind of made it so each droplet is agentic, like it just tries to take care of itself and be responsible for itself, so that I wouldn't get into really complicated logic as far as like looking at all the cells. And it just seemed very natural to me to like say like, okay, I'm a droplet, I'm falling. There's gravity. Oh, there's nothing below me. Oh, okay, I'm gonna fall. Oh, I'm encountering some water. Okay, well, maybe I slosh off, maybe I fill up, depending on what's going on. Here's this cup-like scenario here. So if we unpause, so okay, it's got one. Oh, and by the way, the things in the lower right is the amount of water per cell. In case you couldn't figure that out, you probably did already. So there's two, and we have a max fill of 3. So we get the max fill. Now if I do one more, it's going to kind of slosh off to the left, slosh off to the right. Sometimes it'll rest on top, and then it'll kind of start building up here, and then slosh off to the right, and it'll just kind of keep doing that. And this one, you can see it kind of sloshed off to the right, but then it bounced. It does have this kind of nice effect where it'll kind of shuffle around a little bit. It's not I mean, it's deterministic, but it feels very natural with this level finding mechanic. And so the basic logic is, if the droplet, there's a leveling iteration that happens, but it has to be, in order to avoid jitter, what they call jitter in these water simulations. If it was just like a difference of 1, then you would have things bouncing back and forth a bunch. You'd have these infinite loops, and I was getting a lot of that early on when I was working on this thing. But what I do is I have it set to a difference of at least 2, and so it only starts to do the leveling mechanic once there's a difference of at least 2. So like a 3 to 1, or 3 to 0, or 2 to 0, or something like that. So that way you don't have this jitter or these infinite loops, but you still get some real naturalistic flow, which is pretty cool. And of course, yeah, I have this log on the right to help me with. I added this to help me debug, so I can kind of trace stuff. So like if we let's do a reset here, and so let's put a droplet here. Let's unpause the simulation up here, and the droplet will kind of tell you what it's thinking, so to speak. So it's like, oh, nothing to do here. I'm just resting on top of the solid, and nothing to. Or actually, that one ended up sloshing off to the left. So it kind of tells you what it's thinking, so to speak, and that kind of helped me debug. That helped me catch some bugs where it was like some infinite loops and things like that. So yeah, it's pretty cool. You can really it really starts to, I mean, it really kind of looks kind of naturalistic after a while, especially like if you increase the tick rate. Like, let's bump that up a little bit. I don't know. There's times where you look at it and you're like, oh yeah, it kind of does look like flowing water. So it's pretty neat. So if you want to play with it, it's my full name, aaronshaver.github.io/water-simulation. And it's one of these and then if you want the code itself, it's on my repo here. Or you can, I mean, I suppose you can just do view source, but it's one of these single HTML file type of deals, where it has the CSS and the JavaScript and everything in it. So you've got a lot of styling stuff at the top, and then we've got toolbar stuff below that, and then we have some constants, and then it'll eventually start getting into there's some utility functions, and then there's some eventually we get into some logic, like computing the pressure and stuff like that. So anyway, yeah, I think it's pretty fun to work on, and I got it to a pretty good state. It's not perfect. I think there's still one, I can't remember, there's still one case where it doesn't look very natural. I can't remember. There's some sort of case where it kind of is not perfectly realistic. Like sometimes when it sloshes upward, it's not totally realistic. It's not perfect. Like this one, should it have bounced up onto this solid one here? I don't know. You could. The thing with the water simulation is there's all kinds of different ways to do it, and some are a lot more sophisticated than others. So you could keep going and keep going and keep going until you get something like Unreal Engine 5 or whatever, to where it's like ultra realistic, where you get turbulence and you get all these. I mean, water physics can be insanely complex. But you know, for a pretty basic algorithm for this thing, just with some pressure and some fill, you've got pressure, and you've got a basic algorithm about how it decides to flow. I mean, I don't know. I think it looks pretty realistic, and it's fun to work on. So anyway, thank you for watching.